Hey folks, I am Cameron Worrell and I am a Principal Solutions Architect with AWS. And today we're going to be covering how to enforce your CloudFront origins using AWS WAF and Secrets Manager. And so what that means is we're going to be looking at how you can prevent viewer requests from directly accessing your origin resources behind CloudFront distributions. So as we go through our discussion today, we are going to be covering a number of areas. We're going to start off by thinking about how you can really expand your security out to the perimeter edge without having to re-architect your applications. We're also going to, of course, dive into the main focus of the talk today, which is the specific pattern using AWS WAF and Secrets Manager to enforce origins. And we're going to have a demo around that. We're going to take a look at some of the other patterns that you should be familiar with when you think about origin enforcement with CloudFront, just to kind of round this topic out. And then at the end, we're going to give you some resources that you can take advantage of to quickly get started and start testing and running this type of pattern in your own environments. So if we start off thinking about, kind of a basic web application on AWS, here we have a very standard app. We've got an application load balancer. We have EC2 instances behind that, and we have an S3 bucket. And so there's some basic security mechanisms built into this that are pretty good. So we've got like security groups, for example. We have private and public subnets, and not a bad start. But what do you think we can do better? What other things can we add to really enhance and improve the security posture here? So the first thing we can think about for our website is adding CloudFront. So CloudFront is basically a CDN service that we provide, and it allows you to take advantage of more than 200 edge locations globally. And that gives you not just acceleration of dynamic and static content back to your site and speeding up access for your users, but it also provides a protective layer in front of your origins. So by that, we can do things like offloading the requests from your origins, collapsing simultaneous requests, and then more security specific things like terminating the encryption, the TLS encryption at the edge. And so you can set things like TLS versions that you want to support. We recently added TLS support for 1.3, and that gives you, for example, fewer round trips to establish that TLS session, as well as it gives you support for cipher suites that only support perfect forward secrecy. In addition to those things, we also integrate with CloudFront to services like AWS Web Application Firewall and AWS Shield. And so AWS Shield is our managed DDoS protection service. And this helps with a lot of the malicious requesters out there. If you think about bots, scrapers, nuisance requests, or some type of threat that might be out there, you can integrate using WAF with CloudFront. So as our next layer of protection, let's go ahead and add AWS WAF to our CloudFront distribution. And this is going to help us really mitigate those requests before they get close to our origins. Okay, so when you dive into AWS Web Application Firewall, we have a number of services that you can integrate it with. And what it gives you is a highly configurable, flexible rules engine that you can integrate with services like CloudFront, which we just touched on, as well as Application Load Balancer, API Gateway, and most recently, integration with AppSync. And the way you can integrate the AWS WAF with these services makes it seamless for you, so you don't have to re-architect your application. You don't have to think about re-terminating your TLS or anything complicated like that. It seamlessly integrates and makes it easy for you to get up and running. So diving a little deeper into the WAF capabilities. So again, WAF provides a very robust rules engine that you can configure. And so you can look at incoming requests and make decisions on different conditions to match on. So for example, you can look at the URI, or you can look in the query string of a request coming in. You can look for matching based on things like SQL injection or cross-site scripting. And then you can dial in a condition to match that and decide whether you want to block, allow, or log, which is count those requests. And the pattern that we're going to be looking deeper at today is around looking at the HTTP header and matching on a value for origin enforcement. In addition to that, WAF integrates with CloudWatch so that you can, basically get logging and metrics off of the WAF service. And you can get not only sampled requests, but full logs. So you can get the full JSON delivered header information, as well as the actions that were taken and the rules and things like that with the WAF. So you can merge that into your SIM or into a logging destination where you can do further analysis of those requests coming in. We also have API-driven capabilities for the AWS WAF, so it's integrated with CloudFormation. You can take advantage and run automations this way. And so we provide a number of automations for the WAF that you can get started with, and then you can customize your own. We also have managed rules for the AWS WAF. So this is where you can either by taking advantage of Marketplace using partner rule sets that are available, or you can also use managed rules that are provided by AWS. And again, just want to reiterate, the automation aspect of WAF allows you to really implement, and design patterns that allow you to put the WAF throughout your development lifecycle, work it into your code pipelines so that you can test and automate all of that functionality. You can also quickly push changes out if you need to respond for threats or other things that you need to change your rule sets on. So now that we've added AWS WAF for our web application, we need to prevent those malicious requesters from going directly to our origin resources. So let's dive deeper into that aspect now. So there's a couple of patterns that we see here. So first of all, for S3 origins, the most common pattern that you're going to see that you're probably already familiar with is origin access identities. And this is essentially where you have a user that gets created, that special user that CloudFront uses to access your S3 resources. And you then define a bucket policy on your S3 resources to give them that access the appropriate permissions to read the objects and interact with that. And any other requests coming in will be blocked by that policy. Then you have essentially the other different types of origins. So this is where you think about elastic load balancing or direct EC2 access for your origin, or maybe an application running in your on-premise data center even behind CloudFront. This is where we see using a verification header is the pattern, which we're going to dive deeper into here. And then also using IP allow lists. So this gives you the ability to basically limit access by IP. So we're going to cover both of those, but I want to dive into this pattern with the HTTP header verification first. So when you think about header verification, this ties into a feature within CloudFront. So when you're using CloudFront, you have the ability to define a custom header. And when you configure the custom header, CloudFront is going to add that header to each request that goes back to your origin. So in this case, we've added a header, xOrigin verify, with a value in it, which is basically a secret string value that we have that's out there that gets used. And then once it's added, you're essentially going to perform a verification back at your origin. And that verification can happen in a number of places. So you might do it at the host layer in the application, or you might look at using an ALB Listener rule, or you could do it in the WAF with a regional WAF deployment. And that's really what we want to dive into here more deeply. So this is essentially a pattern where you're going to deploy a regional WAF with your application load balancer. In that regional WAF, you're going to set up a web ACL. That web ACL has a default action of block. Then you configure a statement. So then I'm going to configure that ACL to look for my header and then match based on the specific string that CloudFront has added to that request. And this is basically something that you can implement with application load balancer, API gateway, or AppSync. If it does not match that particular condition with the header, then we're going to basically block that request. So once you have the header configured there, you need to rotate and secure that secret value for the header. That's where Secrets Manager comes in. So Secrets Manager is a service that allows you to securely and centrally store secrets for your workload. So this could be database credentials, could be API keys, and other types of secrets. In this case, we're using it for that verification header value. It gives you central storage, it gives you fine-grained control, so you can set IAM policies around who can access these secrets and manage that at scale. The other thing Secrets Manager provides is the ability to rotate those secret values over time. And this is an important aspect because, in the well-architected framework, we encourage you, it's best practice to go ahead and secure and rotate these secrets over time. Then finally, you have this auditing and monitoring. So you're going to be able to have a trail of how that secret value, how it's been accessed and used over time historically. So this gives you that sort of end-to-end lifecycle capability when you're managing your secrets at scale. So that rotation piece is very important to our pattern that we're diving into today. I want to cover that a little bit here. So the idea is when Secrets Manager needs to rotate that value, it's going to basically trigger a rotation lambda with an event. And there's 4 steps that occur inside of that event. You have a create secret where we generate that random string. Then the lambda has a set secret. So in the case of our verification header, we're setting the secret value both in the CloudFront distribution configuration and in the origin regional WAF deployment. Once that's done, we test it to make sure it's working and the behavior matches what we're expecting. And then finally, if that's successful, we finish the secret. And what Secrets Manager does throughout this process is uses version labels to control and help bring consistent continuity to how we go ahead and manage these secrets at scale, so that if one of these steps fails, it's going to stop and we maintain the integrity of that secret out there in our application environments. So now that we've put some of these pieces together, let's take a look at the end-to-end flow for our specific WAF Secrets Manager origin enforcement. So the way this works is the first step is you have a viewer request that's generated for your web application. Maybe it's a unicorn writing application. In that case, we're going to resolve that. It's going to go to the nearest CloudFront edge location. And from there, you'll have a edge WAF that does some inspection. And if it is not blocked by that WAF ACL, it's going to be passed back to CloudFront. If it goes to the origin from there, CloudFront is going to add that custom header, the origin verify header, and then that header is going to be verified back at the regional ALB at your origin. And so once that is verified, if it gets through there, it's going to be passed back to your backend web servers and response will be processed accordingly. And then finally, you have this rotation, this critical piece where we're rotating and managing this secret value over time. So that gives us kind of the end-to-end high-level flow. Now that you've seen the high-level flow, let's do a demo and see how this works in action. And you can see here that I have a pre-deployed CloudFormation stack. This CloudFormation stack has all of the necessary components for the solution we just ran through. The first thing I want to showcase and go through is we have our CloudFront endpoint. So if I access that endpoint, I have our Wild Rides Unicorn site here, and it actually successfully pulls up our site, and we're able to access that resource. You can see that this came back successfully. This was processed by that Edge WAF and had made it through that web ACL successfully, and this is the behavior we're looking for. However, if I go and do a request to the origin resource, you'll see that I get back a 403 forbidden. So what's happened here is that our request does not have the verification header that we're looking for inside of that regional WAF. And that's the behavior, again, that we're looking for here. We want to make sure we're blocking those direct origin requests. So let's see how this works. So the first thing you'll see in the CloudFront configuration is that we have our domain name that we went to, and we also have an origin configured with our application load balancer back in the region. If I go in, you can see that we have the custom header configuration here. This provides essentially that header field name and the secret value. So these are the fields that are going to be managed by our Secrets Manager process that I just ran through. So you can see that value there. Now that you've seen the CloudFront configuration, let's kind of move back to the origin and take a look at the regional WAF configuration behind this. So in the regional WAF configuration, you can see that we have our ALB association. That ALB is configured for this web ACL. And in the web ACL, we can see there's already been some blocked requests here that are present. And the reason for that, if I drill into one, you'll see that we have an action of block, and that's because, of course, the header for the verification is not present. Again, this is, of course, the behavior we're expecting here. Let's take a look at the rules that enable this configuration. So in the rules, you'll see that we have one condition, one rule, and the action is set to allow. And then the default action for this web ACL is actually set to block. So anything that doesn't match this rule is going to be blocked. And let's now go into the rule itself. So in the rule, we have a statement here. Again, this statement gives us the configuration we're looking for, which is we're going to look at the header X origin verify, and we're going to match on that string, and we're going to do an exact match. So this is the string value that's applied by CloudFront. You'll notice there's actually two statements in this rule. The second statement actually is the same, but it looks at the previous version of the secret. And the reason for this is we want to maintain some overlap of the current and the previous secret versions in Secrets Manager so that when we do a CloudFront distribution update, we don't have a gap where there's propagation time where we're going to block traffic that we actually want to allow. You'll see here that the action is to allow if it meets the conditions in that rule. And that's how the WAF piece works. The next piece of this solution is, of course, Secrets Manager. So let's take a look at that. You can see here in the console, this is the Secrets Manager console for this particular secret. In the rotation configuration, let's go ahead and do a manual rotation immediately. So I'll go ahead and trigger that. You can see we successfully scheduled the rotation. In the rotation, you'll see that it's set for a 7-day interval. That means that it will take 14 days for a secret value to completely rotate out because we're using both the current and the previous. The other thing you'll see here is you can retrieve the current value here. It's simply a key value pair that gets basically stored by Secrets Manager for this use case. And in the configuration for the rotation, you'll also note that we have a pointer to our Lambda function. So let's take a look at our rotation Lambda and see how that works for us in this solution. So here we are in the rotation Lambda now, and you'll see that there's some code here to enable the steps that I ran through, and we provide sample code that gives you a scaffolding to get this going for any custom secrets that you want to run. This code is available on GitHub as well. And then if you take a look at the monitoring for this rotation Lambda, you'll see that it's actually already been invoked multiple times successfully. But I'd like to highlight here in the logs that you'll see when we rotate this Lambda, we're going to log those 4 steps that I mentioned earlier, which is, again, we have the create secret step, right? Then we have the set secret step. We have the test secret step and the finish secret. And of course, you're not logging the secret itself here, but you are logging information about the process that would be useful if you need to debug this. This gives us the functionality of the solution end to end. And you can see, since we've triggered the rotation, we're already doing a CloudFront propagation. We're actually updating that distribution now. And now we have sort of our Wild Rides unicorn site up and running with our origin enforcement in place. All right, so that was the demo. Now let's take a look at some of the additional patterns that I wanted to cover in the talk today. The next one is if you are using ALB and WAF is not necessarily an easy option for you to implement for some reason, you may want to look at using listener rules. So a listener rule is basically a layer 7 rule that you can implement with application load balancer. And you can essentially, what we're going to do here is you can look at layer 7 properties of the request and then route that request to target servers behind it based on that. So in this case, we have a layer 7 listener rule that looks for the header with the values of the secret. If it meets that criteria, it's going to route it back to our target servers in the back end. If it does not, we have a fixed response rule that is going to do essentially just send a 403 fixed response back. And so this could be an option for you to look at. I would say I would look to the WAF option first, but if for some reason that's not an option, you might want to take a look at this pattern. It could be complex if you have to manage the origin enforcement listener rules with other application listener rules, but it is something that's out there that is worth kind of including here today. Another way is for the origin enforcement might be to perform that verification back at your EC2 instance, either at the host layer or in your application. So this would be implementing some type of verification, maybe using Apache with mod security or something like that, where you're doing the verification inside of the web server software, or you could do it in your application code. So again, of course, this is not the optimal approach. It is something that you may want to look at, but you would have to figure out the pattern for managing this at scale, run configuration management to push this out across your fleet, or merge the functionality of verification into your code, into your deployment pipelines. And then the last origin enforcement pattern I want to cover here is using an IP allow list. So this is a kind of a layer 3 type of approach where we use IP CIDR ranges. So we have IP ranges that we publish that are listed out for CloudFront edge locations. Once you have that, we can basically provide this JSON document. If it changes, you get an SNS push and you subscribe to that topic. That way you can update your automation. But what happens is you're going to take those IP ranges and then propagate them into a type of rule set inside of your origin configuration. So that could be a WAF IP set. Most commonly, I see this with security groups, or you might do it even in the host layer as well, or an on-premise firewall possibly. I have seen customers use this in conjunction with header verification approaches as well. So another one that is worth mentioning today. All right, so now that we've added our origin protection and enforcement, now we want to think about what if we want to protect our site from DDoS threats. That's when AWS Shield and Shield Advanced comes in. So Shield comes in 2 tiers. You have standard as well as advanced. And standard is included with the AWS platform. It's designed to protect against common layer 3 and 4 attacks. However, for more sophisticated protection, and if you want visibility into CloudWatch metrics and better sort of more sophisticated monitoring, this is where we really encourage you to look at Shield Advanced. So Shield Advanced essentially is going to do things like give you additional metrics, baseline your application traffic over time, and then be able to look for anomalous activity that's consistent with DDoS attacks. You have access to our Shield response team to help you, prepare or respond to DDoS threats. And you also have, with Shield Advanced, it will include AWS WAF and AWS Firewall Manager at no additional cost for protected resources. And that can be important for a solution like this, where you have 2 WAFs. If you're using the WAF Secrets Manager solution, you have 2 instances of WAF deployed. So the next thing is, once we've added all of the security layers, how do we manage this at scale? And that's where Firewall Manager can help. So AWS Firewall Manager essentially helps you to centralize management across AWS WAF policies and ACLs AWS Shield, as well as VPC security groups. And so it allows you to centralize the control and administration of these policies using integration with AWS organizations. And so once you have this, it's going to be easy for you as a team to really set baselines and centralize the preferred policies, the preferred WAF-Web ACLs and security group patterns, things like that, throughout your accounts and across your teams. From there, you can audit and wrap guardrails around that process to make sure that the policies deployed aren't deviating from those baselines that you've set. When you have an event where there's a configuration drift, or if you have a resource that is not in line with the policy, then you can decide, do you want to just notify on that, or do you want to go ahead and automate some type of remediation to bring that resource in line with the particular policy that you're after. So the Firewall Manager can really help with that aspect of management at scale. All right, so let's go back and look at our basic application. So we started off with some very kind of starter level security in it, but we added quite a bit. I mean, think about the things that we added as part of the process we went through. We went ahead and we started off by putting CloudFront in front of our application. Then we took and secured our origin and put in an origin enforcement using WAF and Secrets Manager. We also turned on Shield and Shield Advanced potentially for protection against DDoS threats. And then we implemented Firewall Manager to really help us manage this at scale. So this is really kind of the complete picture of the solution we put in place. And now we're off and running with our wild rides unicorns, and everything's working as we intend. So that wraps up this talk today. I appreciate your time. Again, there is a demo solution deployment you can take advantage of. All this code is available for you. There's a step-by-step walkthrough you can go through to quickly get started in your own environment. A few other resources you might want to be familiar with and take advantage of here, and some other sessions as well. And I thank you for your time today. And appreciate, again, if you have feedback, we would love to hear that. And there's going to be a link for that as well. Thank you.